Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we are going to discuss, or I'm going to show you the solution of what we call Pspm questions from topic 10, application of differentiation. Okay, so I have picked up we call 4 to 5 questions just for helping you to recall, to get an idea for you to continue what we call with the rest of the question. I think there are all around 21 questions overall. Okay, so with this 4, hopefully it helps you to continue with the rest of it. Okay, without wasting so much time, let's continue with the first one then. Okay, these are all the questions that we call select and get ready. Now, the first one here. Okay, question number 3, given the function of fx equal to 2x to the power of 4 minus 16x squared plus 14. So find all the values of x such that f prime x equal to 0, meaning we are going to differentiate this. F prime x equal to 4 times 2 equal to 8x cubed, 4 minus 1, okay, minus 2 times 16, 32x, and differentiate 14 equal to 0. So make it f prime x equal to 0. So when f prime x equal to 0, meaning it is 8x cubed minus 32x equal to 0. So factorize 8 with 32, take it 8 here and 1 of the x. So here we get x squared minus 4. Now 8x from x squared minus 4, we may continue, we call simplify, we call factorize this with x minus 2 and x plus 2. So from here, we can list down all the value of x, which is x equal to 0, x equal to 2, and x equal to negative 2. Okay, so these are all the values of x such that f prime x equal to 0 for question A. Now, by using second derivative test, determine whether fx is a relative maximum or minimum and the values of x obtained from the part A. From this question A, we already list down all the values of x, which is 0, 2, and negative 2. And we're going to use this value substitute into the second derivative test. So it means that here, we are going to differentiate this for a second time. F double prime x equal to 3 times 8, 24x squared minus 32. Okay, so we got three values of x here. For the first one, when x equal to negative 2, so then f double prime negative 2, which is 24 negative 2 squared minus 32. And this one, negative 2 squared equal to 4. 4 times 24, which is 96 minus 32. 6 minus 2 equal to 4. 9 minus 3 equal to 6, which is positive. So then the positive value, it tells us that, okay, with the conclusion that at this point, it gives us a relative minimum. Okay? When x equal to 0, so then f double prime 24, okay, 0, which is 24, okay, 24 with x equal to 0 squared minus 32 times 0, everything 0 here, 0 minus 32 equal to negative 32. So with negative here, we come up with conclusion that is a relative maximum. Okay, and then when x equal to 2, then f double prime 2 equal to 24, 2 square minus 32. 2 square equal to 4 times 34 is 96 minus 32 equal to 64. Another positive value just like this. So we come out with a relative minimum. Okay. So that is the first one then. Question number 3. Question number 6 is, okay, a conical tank. Okay, so just imagine that, okay, sorry. Okay, a conical tank, cone, okay, cone with a height given that the height of 12 meter, and then the surface diameter from this ring through the center and then end up here, and the ring of the circle of the surface here, diameter equal to 4, meaning the diameter equal to 8 and the radius equal to 4. Okay, the water is pumped into the tank. So we fill out the water into this tank with a rate of 50 meter cube per minute. Okay, how fast is the water level? Okay, now class, just imagine that right now is an empty tank. So we start filling water inside, and let's say in a few minutes it has reached to this high level. So from the bottom to this level, we assume that this is something called H1. Okay, let's say this is center of the cone. You make this nice straight line here because I'm not using the ruler here. Okay, so then H1, then the radius is R1. Okay, after a few minutes, the water level increase. So at this point here now, it is H2 with a new radius, which is R2. Okay, and after a few minutes, then the level increase, and now you come up with H3 and with the radius, the new radius of this R3. Okay, so H3 is greater than H2 is greater than H1, and also with R3 is greater than R2 is greater than R1. Okay, now from the information given here, the water is pumped into the tank at a rate. So class, when I mention about rate, meaning we are talking about the changes of something. At this point, the water pumped into the rate, and we call into the tank at the rate. It has something to do with time. Okay, so look at this one here now. Meter cube. Meter cube is we call volume. Okay, and then per minute, time. So the changes of volume respect to the time. And in this question he given here, which is 50 meter cube per minute. Okay, class, look at we call the diagram of the picture here. When the volume increase, there's a changes of volume. Okay, and look at this one here now. It's also has to do with the changes of the height from H1 to H2 and H3. So changes of height and also changes of radius, because this is cone, not cylinder. For cylinder, if we pour the water inside from one level to another level to another level, the radius are equal. So there's nothing changed. We call it had nothing to do with the changes with the radius. But for this cone, yes, it is. And it is changes respect to the time, from 1 minute to another minute and another minute. Okay, now, from this question, water is pumped into the tank at a rate of 50 meter cube per minute. How fast? Fast means that we have to do with time. And then the water level increase. It is about height or radius? Yes, it is height. Okay, the water level increase, it has something to do with height. So then, dV dt equal to dv and dt. So I mentioned, we agree just now it is a changes of the height. So then it is dv dh and dh dt. Okay, dv dt is already given in the question, so we get this information. How fast is the water level increase? Height with that time. So this is the one that we are going to find out as our final answer. So this is a question now. But then, what about dvdh? dvdh, let's write down the formula of the volume. V equal to, this is cone, so 1 over 3 pi r square with the radius, we call the surface of the conical tank here is circle, pi r square, and then the height is. Now we got three variables here, v, r, and h. So we are going to find out the dv dh, meaning what about this r? Okay, let's get back to the question here. We call the radius of the surface of this circle for the cone is r, and then divide, we call ratio with the height, which is with the height here. So radius equal to 4 and the height is 12. 4 with 12, which is 1 over 3. So r equal to 1 over 3 and h. So class, we are going to substitute this value, this equation r equal to 1 over 3h into this r. So then pi r equal to 1 over 3h square multiplied with h, and then 3 square equal to 9. Okay, 9, 1 over 3 cube equal 1 over 3 square equal to 1 over 9. 9 times 1 over 3 here is 1 over 27 pi h square multiplied with h, then come up with h cube. Okay, class, I'm asking you again, do you find any variable of r left here? No, right? This is only now between v and h. So then dv dh equal to, okay, differentiate the power of this 3 here. Now 3 over 27 pi h, 3 minus 1 equal to 2. Or simplify this as a 1 over 9 pi h square. So this is the one that we're going to substitute here. Okay, so then dv dt equal to 50 meter cube per minute, and then dv dh 1 over 9 pi h square dh dt. Okay, now how fast the water level increasing when the depth of water is 6 meter. So we substitute h equal to 6. So then 50 equal to 1 over 9 pi 6. Okay, the h equal to 6 square dh dt. 6 square 36. 36 divided by 9 equal to 4. So 50 equal to 4 pi dh dt. So then dh dt equal to 50 divided by 4 pi, or because simplify this, divide by 2, 25 over 2 pi. Okay, now the unit for height, meter, yes, meter, and then time, minute. There you go. Okay, next, find the relative extremum of the curve y equal to x cubed minus 4x squared plus 4x. So then y equal to x cubed minus 4x squared plus 4x. Okay, so then y prime or dy dx equal to 3x squared minus 4 times 2 equal to 8x plus 4. Okay, so let's finally recall, make it y prime equal to 0. So then 3x squared minus 8x plus 4 equal to 0. Okay, it's either we are going to use the method of factorization, or might be completing the square, or using the formula. Okay. Okay, so we factorize this. Then 3x and x. Okay, this is we call product of root. Is we call, let's say, a pairing of numbers of 1 multiplied with 4 or 2 times 2. And then we got sum of root, the difference, or might be additional. Okay, addition or subtraction, or we call summation, or might be difference. Okay, now if I use 1 and 4, so 3 times 1 equal to 3 plus 4 equal to 7, you would get you 8 here. Or 3 with 4 equal to 12, and then minus 1 equal to 11, so it will give you 8. Let's try with 2 and 2 here. 3 times 2, 3x times 2 equal to 6x, and then 2 times x equal to 8. Okay, so it is 3x minus 2, and then x minus 2. So 3x times x, 3x squared. 3x times negative 2, negative 6. Negative 2 times x, negative 2x, so negative 6x minus 2x, negative 8x. Negative 2 times negative 2 equal to positive 4. That's it. Okay, so now 3x minus 2 equal to 0, then x minus 2 equal to 0, then x equal to 2 over 3, and x equal to 2. So there are two values of x here. Okay, find the relative extremum. Okay, we can use the first derivative test or second derivative test. Okay, in this question, it not mentioned about the first derivative test or second derivative test, so we may use any of the method. Okay, I'll show you both. First derivative test, from here, okay, we use a table. Sorry, that. From negative infinity up to 2 over 3, 2 over 3 until 2, and then 2 to positive infinity. Okay, so now dy dx. So just think of, okay, let's just imagine that this is a border between this range and this range, which is 2 over 3, and here the border here is 2. So, which is, okay, just think of any value that less than 2 over 3. Less than 2 over 3, 0. Okay, so substitute 0, substitute x equal to 0 into y prime or dy dx. So 0 and 0, we get 4, positive 4 here, and it is positive. Okay, and then between 2 over 3 until 2, make it 1. Okay, let's say x equal to 1. So substitute 1 here into y prime of dy dx here. So 1 square is 1. Okay, 3 minus 8 equal to negative 5. 3 minus 8 equal to negative 5. Plus 4, negative 5 plus 4 equal to negative 1, negative. Okay, and then greater than 2, let's make it 3. 3 squared equal to 9 times 3 equal to 27. 27 plus 4, 27 plus 4, 31. And then negative 8 times 3 is negative 24. So 31 minus 24 is positive. Okay. So come up with a conclusion that it is increase, decrease, and increase. Class, dy dx is actually what we call a gradient. Okay, kecerunan. Okay, gradient. So when gradient is increased, gradient decrease, and gradient increase, actually that we can just imagine that this is the graph that we will get from the equation. Okay, increase, decrease, and increase. So this is the we call the graph that we will get if we sketch the graph of this. Or let's say, I think that I prepared we call the graph of this. Okay, y Okay, I think that we got a problem with these apps. Sorry. Y equal to x cube minus 4 x squared plus 4. There you go. Okay, so this is the graph. So you compare the graph with that graph that I we call sketch here right now. Okay, so this is where the x equal to 2 over 3 and x equal to 2. Okay, now what is the coordinate of this stationary point? What is the coordinate of this stationary point? So substitute the value of x 2 over 3 and 2 into the function of y. Okay, so when x equal to 2 over 3, then okay, y or fx, okay, y for 2 over 3 equal to 2 over 3 cube, x cube minus 4, 2 over 3 squared, plus 4 times 2 over 3. So once you get the value of this, so list down 2 over 3 and something here is the coordinate of this, the stationary point. And also y x equal to 2, the second value of x here. So then 2 cube minus 4, 2 square plus 4 times 2. Okay, you got the value here. So this is the coordinate, next coordinate, second coordinate of 2, and something here is the stationary point for this graph. Okay, now class, if I continue this discussion here, okay, this is using the first derivative test. So at this point, here is a here is a relative maximum. And here is relative minimum. Okay, I use the second derivative test. Okay, second derivative test, meaning I need to differentiate this for a second time here. Y double prime equal to 2 times 3 equal to 6x minus 8. Okay, and then I'm going to use the value of x that I get from the first derivative test here, the value of x equal to 2 over 3 and x equal to 2, substitute into y double prime. Okay, so when x equal to 2 over 3, then y double prime 2 over 3 equal to 6 times 2 over 3 minus 8. 6 divided by 3 equal to 2. 2 times 2 equal to 4. 4 minus 8 equal to negative 4. So the value of negative here, the value of negative 4, we come up with the conclusion that is a relative maximum. See, it's a relative maximum here. And then, when x equal to 2, so y double prime 2, which is 2, okay, no, second derivative 6, okay, 6x minus 8. 6 times 2 equal to 12 minus 8 equal to 4, positive value, so we come up with a relative minimum. You can see here is a relative minimum here. So we call the situation whether it's a relative extremum, maximum or minimum using the first derivative test using the table or second derivative test. Okay, substitute the value of x from first derivative into the function of second derivative of y here. Okay. Okay, next question. Now, given the function where x cannot be equal to 0, find the coordinates of stationary point and determine whether it's a relative maximum or minimum. Okay, now fx equal to x squared minus 6 over x. Let's make this one as an x squared minus 6x power of negative 1. So f prime x equal to 2x negative 1 times negative become positive 6x power of negative 2. Okay, so determine, find the coordinate of stationary point and determine relative maximum or minimum. It did not mention about using the first or second derivative test, so it's all up to us then. Okay, so make it equal to 0 here. F prime x, okay, let's make this one f prime x equal to 0, so then 2x plus 6x power of negative 2 equal to 0, or 2x plus 6 over x squared equal to 0. So I'm trying to simplify this, multiply the denominator and also cross multiply. So 2x times x squared, 2x cubed, plus 6 times 1 equal to 6 divided by x cubed equal to 0. Multiply x cubed on the left side and right side. Yet this one is still 0. Okay, so 2x cubed plus 6 equal to 0. Then 2x cubed equal to negative 6. X cubed equal to negative 6 divided by 2 is negative 3. Okay, use the calculator, so then x equal to negative cube root of what we call 3 here. Okay, or this one here, make this as a negative cube root of negative 3. And if you substitute, change into the value of this in decimal, this is negative 1.4422. Okay, from the first derivative test, then we get the value of one value of x here. So then next, determine whether it's a relative maximum or minimum. Okay, let's say if I use a table to check whether this is going to give us a relative maximum or minimum. So from negative infinity until negative 1.44. Okay, and then from negative 1.44 to positive infinity. So then dy dx. Okay, less than negative 1.44. Okay, just imagine that is a negative 2 here, and greater than this. Okay, this is negative 1.44. Okay, negative 1 and also 0. So greater than, that makes our life easier. Take a 0 as a value of x then. Okay, substitute into f prime x. So f prime negative 2, which is 2 times negative 2 plus 6 divided by negative 2 squared. Negative 4. Okay, negative 2 square equal to 4. So then negative 4, we call this one negative 4, okay, and positive 6 over 4. 6 over 4 or 2 over 3. Okay, so negative 4 times 4 is negative 16 over 4 minus 6 over 4 plus, which is negative 10 over 4. So when negative, the gradient is decreased, and then f prime, let's say x equal to 0. Okay. Okay, for this one here. Okay, class. So I'm not going to take the value of x equal to 0 for this case. Okay. The reason is, okay, f prime x. This is 2x plus 6 over x squared. So when x equal to 0, the whole function is undefined. So take the value of 1 here. Okay, x equal to 1. So f prime x equal to 1, which is 2 times 1 plus 6 divided by 1 squared. So 2 plus 1 squared is 1, 6 equal 6, and then 8. So the gradient is increased. So that the conclusion, this is an increase, the gradient is decreased, and the gradient increase. Okay, so what is is a relative minimum. Okay, for this one is a relative minimum. Okay, according to the question, whether it's a relative maximum or minimum. Give the coordinates correct to 3 decimal places. Find the stationary point. Stationary point means that at this point here is negative 1.442. Okay, in between here, from decrease to increase, the stationary or the changes from negative to positive is negative 1.2442. On we call the axis of x and y axis, we need the coordinate. When we talk about the coordinate or points, we need two values, which is x and also y. So in this case, substitute into, recall the value of negative 1.422 into the function of fx. So that f negative 1.442 into then negative 1.442 square x square minus minus 6 divided by negative 1.442 squared. Okay, for this one you may use a calculator. Okay, you should get 6.241. So the coordinate of this is negative 1.442 and the value of y is 6.241. Okay, that's all for today, class. I do hope that this video helps you recall to get a picture of the question for the Pspm, and hopefully it helps you to continue with the rest of it. So that's all for today. Thank you very much. Good luck for Pspm. Okay, take care of yourself. And also take care of yourself. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.